talks. I hope you all are getting as much out of them as I am. And so could all of the speakers for this round of lightning talks please come up here to the right, and we'll get started shortly. Just as a quick reminder, these are 1 to 2 minute talks, and there are no slides, no questions, and hopefully new collaborations. So with that, we'll go ahead and get started with Katherine.
Hi, everybody. I am Katherine Robinson, the other Robinson at this meeting. I'm a graduate student at the University of Hawaii, and I study lunar interior water, so water that was accreted with the moon or added very early in the moon's history, a little different from the surface water that we've been hearing a lot about so far during this meeting. Anyway, I'm giving a talk today at 11:20 about water and new results from lunar appetites, including some of the lowest delta deuterium values we've measured so far from the moon, which may represent a primitive component preserved in the lunar interior. So 11:20 and in the other room. Thank you.
Hello everyone, my name is Gen, and I'm going to my second year of graduate studies at State University of New York in Stony Brook. There I study with Dr. Tim Glotch about infrared spectroscopy and remote sensing. So there are a lot of processes that go into this, but they start with the fundamental understanding of how light interacts with materials and then gets scattered. The materials that I focus in particular are fine-grained particles, like those on the planetary regolith. And the physics of light scattering for these fine-grained materials or particles becomes really important when trying to interpret remote sense data, which becomes important again for robotic missions or sending human astronauts to other planets. And we want to get as much information as possible before sending anything or anyone there. So to do that, the fundamentals start with the physics of light scattering, and that is why I'm interested in this subject. So I will be in room 106 for the poster sessions today and tomorrow to talk more about this. And my name is Gen, and thank you for your attention.
Good morning, everyone. My name is Brian Shiro. I'm from the University of Hawaii, where I'm a PhD student there in the Department of Geology and Geophysics. I also happen to be a civil servant with NOAA as well. I'm here this week presenting work on HI-SEAS, which is Hawaii Space Exploration Analog and Simulation. It's a really exciting program on the Big Island of Hawaii, where we're bringing people together to explore techniques and procedures for exploring the Mars and other planets. I've done a number of planetary analog projects in the past that have led me down this path. I really enjoy merging Earth and planetary exploration. I've been to Devon Island, for example, and prospected for groundwater with electromagnetic methods. I've been to Antarctica using seismometers to look beneath the ice at mountains beneath the surface. I've done a resistivity survey with the NASA Astrobiology Institute looking for permafrost on the summit of Mauna Kea, for example, and done a seismic refraction project out in Utah as well, which was really fun because we found buried paleochannel features, which are potential areas to look for life on Mars. And now through the HI-SEAS program, we're directing a number of geologic field activities with human crews and gearing up for a lava tube project using ground-penetrating radar to peer beneath the surface. So what ties all my interests together is exploration, whether that's Earth, ocean, or other planets, and how humans can learn to live off the land, find resources that help enable exploration. So again, I'm Brian Shiro. Talk is tomorrow in this room at 2:30 about HI-SEAS. Thank you.
Hi, my name is Rachel Caston. I'm coming from SUNY Stony Brook, where I work in Bruce Demple's lab. I am a fourth-year graduate student in genetics, which I know is not what you were expecting to hear. I got into genetics because I'm actually an identical twin, and I got all sorts of questions growing up about genetics. So my dissertation work is on aging and DNA repair and how our cells repair their DNA as they get older so that you normally don't get diseases like Parkinson's and Alzheimer's, basically how cells avoid that. For a project more relevant to you, I'm looking at human exploration and protecting our astronauts. So basically, of all of the big issues with trying to build a more semi-permanent moon base, one of them is lunar dust and breathing it in. So the short-term effects of that you would expect to be things like respiratory issues, asthma, but there's also more long-term effects to be considered. So if the lunar dust is causing DNA damage, that could lead to things like cancer or neurodegeneration. And those are things that you wouldn't see effects of until months to years after the astronauts returned. So we need to know what sort of symptoms to be looking for in the long term, and or if there's a way to prevent these things from happening to begin with. So I'm giving a poster. It's number 9B. I think it's room 120. And again, my name's Rachel Caston. Thank you.
Good morning, everyone. I'm Shiro from Brown University. I'm looking at lunar surface hydration with MCube data. Particularly, I'm interested in the hydration variation diagonally, latitudinally, and varies with cumulative time. And today I'm going to give a talk to talk about the hydration in lunar pericarp deposits. I'm trying to answer the origin, formation, and retention of those hydration because they are potential resources for water, like in future human being can drink it. So if you are interested in, please stop by. And my talk is just after Jim Hader's talk in the parallel session. So after you hear Jim's talk, please stay with me for another 10 minutes. Thank you. This is Shiro from Brown University.
Good morning, everybody. My name is Dan Moriarty, and I'm a fifth-year graduate student at Brown University working with Carly Peters. So I've been looking at the South Pole Aitken Basin using moon mineralogy mapper data. So specifically, I've been looking at central peaks and the mafic mounds, which we've found to be a somewhat enigmatic topographic high in the center of SPA. So if you're interested in this, I have a talk on these topics in this room in about 1 hour from now. So stick around if you'd like to hear more. Thank you.
Great, thank you all, and one more round of applause for all of our speakers this morning. And now we're